Hello, everyone, and welcome to our webinar today. I will give the stragglers a few minutes, maybe 1 or 2 minutes to join, but I want to welcome everybody who joined right at the top of the hour here, and we're pretty excited for the conversation today. Before I jump in, maybe some housekeeping notes. So our presentation today, we're going to record that for everybody who has attended as well as has signed up but has not attended, so they will get the recording. If you have to leave early, that's not a problem. We're more than happy to send that out after the fact. We're certainly excited. We had well over 30, maybe even 40 by about 15 minutes before the webinar, 40 organizations sign up for the presentation today. So definitely excited to see the interest in that. Any questions that anyone has throughout the presentation, I would encourage you to put those directly in the chat right in here, and we can address those at the end. We'll spend some time to address those questions. Perhaps with that, it's 1 minute after, so we'll dive into the webinar today. We're obviously focusing on VPN-less access to industrial control systems. So how you connect to these systems without using a VPN, ensure you have access, and then ensure everything from a security and compliance perspective as well, off the public internet and things of that matter. So you're going to be seeing, if you don't already, two faces today. So myself, which is probably the less important one, and then my CTO, Nick St. Pierre. Nick, if you want to say hello.
Hi, John. Thanks, John. Hi, everyone. I'm, as John so nicely introduced, the Chief Technology Officer here at Agilicus. So I drive a lot of the product functionality and technology, both on the front end and back end, that our customers get to see. And happy to be here today on actually one of my first webinar with Agilicus. So looking forward to complimenting John's stellar performance to date.
I hope you make me look good, Nick. We're happy to have you. With that, for the folks who are unfamiliar with Agilicus, whether you're a new face or you're just attending our webinar for the first time, a quick overview. Agilicus, we're a cybersecurity company first and foremost. We focus on providing secure access to critical systems. Our focus is you can access that system on any device, no matter the use case, whether it's remote desktop, an HMI that you have, a SCADA system, PLC, or other environments as well. The entire premise behind what we do is provide frictionless access without a VPN and without new hardware in a given environment. You'll hear us talk about concepts including leveraging your existing credentials, keeping these critical systems off the public internet. But of course, it all comes down to the bottom line, and that's reduce the time, cost, and complexity that it takes to connect and support these systems remotely. On that, a little more background. The markets we serve, we span many markets. The most predominant ones that we see use cases in are the ones in front of you: public sector, utilities, oil and gas, marine, manufacturing, and then generically IoT. This is not an exhaustive list by any means. Healthcare is another great example. However, these are the primary use cases, primary sectors we support. From the discussion today, we're going to cover 3 main areas. So we're going to look into the problem area itself. So the challenge is really accessing critical networks and challenges that might be associated with that. The gap that we're going to explore is this security versus access. We hear that a lot in terms of terminology. We also hear the OT versus IT, but the gap itself is going to be this concept of security versus access versus security, and that dynamic. Then at the end of the webinar, or towards the second half, I should say, we're going to go into a deep dive in terms of what does this VPN-less access actually look like, and how can you start to achieve some of these business objectives where you can ensure access without compromising the network itself. To begin, what I wanted to provide is a little bit of a reference to a report done by ISA. So for those unfamiliar, ISA is International Society of Automation. I'm sure you are familiar with this. They've been around for a long time. They are leaders in various areas: operational excellence, global standards, and the like. They had a report where it was focused on the common ICS cybersecurity myths. There's 2 of them that stand out that's relevant to the discussion today. The first one would be what's on this slide here, the unbreachable firewall. That's extremely relevant. ICS security generally is all about preventing unauthorized access into these networks, protecting these resources. This is often achieved, firewalls as a starting point, often ends with very complex rules and policies that are in place, but the entire notion is preventing unauthorized access. It's just rather unfortunate that this often leads to limiting legitimate access in the process. So what we're going to cover today, it's all going to come down to the network design. We're going to show you some examples later of how things are done today, how we promote doing them. And then, the bottom line is that firewalls are a must, but at the same time, firewalls are only as good as the policies that are proven around them. This leaves room for a lot of human error on that. And then with that, I actually want to dive into number one. So that I've provided a little bit of foreshadowing on. I didn't do a great job of blurring it out, but you've likely already guessed it. It's the modern air gap, or the air gap, as many refer to it. To understand VPN-Less access, we must first understand the air gap and how traditional access and the traditional air gap doesn't quite cut it today, and why we're looking at these future concepts. So what it is, an air gap, I'm sure everybody knows. We hear this concept a lot. It's really the gold standard. It's almost mythical at this point. This is what everybody hopes to achieve, but it's very difficult to do so. But when people say air gap, they're really referring to keeping networks separate. So an air gap is a security measure that ensures that one secure network is physically isolated from other networks. Your OT network separated from your corporate network would be a great example of this. And with that, just to test if everybody's engaged, I want to run a quick poll. I promise I won't do this to you throughout the webinar, but I want to make sure everybody has their coffee in their hand and are ready to dive into the next part. So on that, I'm going to start a true-false poll that should pop up for you. And the question is, do you agree with what you see on this page in terms of my ICS network, industrial control system network, is absolutely air-gapped and isolated from the internet, other corporate networks, and therefore there's no security risk, there's no cyber risk. So I'll let a few answers come in. Feel free. Nobody's getting marked on this. We're not going to hold it against you. So I see. Exactly. I see a bunch trickling in, so that's excellent. And I will turn around and publish the results. And so hopefully you guys can see that. With that, now that I've tested that everybody's awake and ready to dive in, what we're going to dive into first is the traditional VPN approach. What we're trying to achieve in all these situations is the air gap, but let's start with the traditional VPN approach and some of the problems that are associated with it. Often these networks are separated. I think whether we're going to use a corporate network and just generally a secure network, this could be a manufacturing facility, a water, wastewater facility, what have you, hospital. But just generically, these networks are separated for good reason. And then a common scenario is, okay, now you have a support vendor, maybe it's an individual, maybe it's a company, that needs to support that HMI that you have on this secure network. It's about to go down, you want to prevent it from going down. What do you do? Well, simple answer is hand them a VPN. Why do you hand them a VPN? Because you know this works. They can get in, they can access it. It's what you've been doing for a long time. But the problem with that is that there's an air gap that's in place. And you think, my air gap's still intact because it's separate from the corporate environment, but now you have this loose end, if you will. At this point, you're still thinking the air gap is solid, but then there's other variables as well that you might not be thinking about, right? So let's look at these IoT sensors that are bottom right of this screen. Well, those IoT sensors that might be monitoring equipment and simply pulling out data points into a cloud environment, somebody wants to view that. And so those sensors go into some cloud environment, and then maybe an executive, maybe somebody at the headquarters is using that data for something. It could be going into a dashboard. It could be simply being merged with other sites, and now those sites are connected. So there's two loose ends now that aren't accounted for. So you have this user, valid user, connecting in to support the HMI. You have these sensors going across. The question is this the best way to do it when you've invested all this money to have this air gap? If you go one step further, let's look at that support vendor. They're actually at home. Generally, a lot of us have been working from home for the last little while. When's the last time you patched the printer that sits on the corner of your desk? It doesn't always happen. And so there's questions that come up now. So we've now created a door on the firewall. You've invested into put a very good firewall at this facility on this network, and we created a door there. And by allowing that door to open for sometimes it can open for anything else that unintentionally comes along with it. Even worse than that, if something does come along with that, if something does get into a printer that's not patched on a home network, it can move laterally onto that user's device, and then that user has a VPN, which fundamentally is a long Ethernet cord to that secure network. And a VPN, as we likely know, is on-off access. You either have access to the entire network or you have no access, you don't have a VPN, the cord's cut. And so this means that anything good, the user can get through, but anything bad that may or may not come intentionally from that user can also walk across this network, and then once in that network, can walk across to other things. So at the end of the day, the network that many thought was air-gapped is not. And so the logic changes. You may think that this is an air-gapped network, but the logic is actually, even though the corporation has invested millions of dollars into corporate security for their corporate network, they've still separated their OT network because the corporation doesn't trust those networks to be connected. But they're trusting a third-party vendor on an unmanaged device connecting from home to connect to that secure environment, even though they don't trust their corporation, which they know they've spent millions of dollars in to connect that. So it's a bit of a chicken and the egg situation in terms of someone needs access. Absolutely, that system has to keep running. But knowingly, these VPNs have been given out when they break the security that you've invested in. So we can start to see how this starts to break down. Obviously, you can multiply this out. There's never just one vendor. There's multiple vendors. Each one vendor, you're not just their one customer. They're not just the manufacturing facility. Just isn't just a single customer of that vendor. They support hundreds. So you multiply the risk out by whatever number you choose at this point. It's quite large. And that's fundamentally where the VPN starts to break down. An air gap must be achieved, but it's this myth of the air gap is secure is being busted largely due to a VPN. And it's driven by a legitimate need that systems need to be accessed, to be supported for the sake of the business. The business needs to stay running. These machines need to stay functional. The factory floor can't go down. The water treatment facility can't have a lapse from a system. It needs to be supported. If there's faults being shown, somebody has to get there immediately before it goes down. And when it comes down to it, the VPN is just simply no longer practical. We live in a world where everything's interconnected. The more technology we introduce, the more risks we have. We can see anything from real-time monitoring to sensors, data being streamed, cloud environments. It's very complex. And often when we talk about security and we talk to IT personnel, they don't always accept the fact that these systems need to be serviced. And so that's where we start to get into this conversation about access versus security. And so my hope is by the end of this webinar, we can find a common place where access and security can obviously coexist. But the main thing that I want you to remember going into the next few slides, access is a must. Those systems should ideally be air-gapped, but at the same time, they need to be supported. So there's a few different concepts that we're working with here. And the last thing that I did want to highlight is this quote. So this is a quote by a former director for the Department of Homeland Security. So his quote was, in our experience, and he conducted many research on this topic, in our experience in conducting hundreds of vulnerability assessments in the private sector, in no case have we ever found the operations network, the SCADA system, or the energy management system separate from the enterprise network. On average, we see 11 direct connections between those networks. In some extreme cases, we have identified up to 250 connections between the actual producing network, so the production network, and the enterprise network. All this to say, VPNs and the traditional air gaps often create a false sense of security. They're there because they're a necessary tool up until this point. However, there are security risks that are built in inherently. At this point, you've invested a lot of money into firewalls to stop people from getting into those environments. The VPN allows them past the firewall into those environments. It's something that's not going to work for much longer. And we'll see that in a few slides where we start to introduce some of the standards that are diving into this. So for the next little bit, instead of holding on to the belief that the VPN, the air gap is secure, let's, for the rest of this webinar, reset, and we'll assess what are the requirements that we're actually trying to hit when it comes to ICS security. We'll provide some concrete measures in terms of how we address cyber risk in this framework. And then all while everything is rooted in the fact that it comes down to access. Access is needed so folks can get their job done. And so with that top of mind, let's start with this. So securing OT networks, what are we actually trying to achieve? So it's great, I need to achieve access, I need to do this, we need various things individually, but at a strategic level, what are we trying to achieve? So we first need to protect those systems. We all know the vulnerabilities that exist. We all know how some could be turned into bombs, some can harm the public, what have you. So they need to be protected from bad actors, from human error, from just general threats. That's the first point. So the second goal is those systems need to be protected from disruptions and outages. Similarly, controls needs to be maintained at all times. Safe operation needs to be in place. We're trying to increase uptime, operational efficiency, production. We're trying to ensure the business is running and functional. And then of course, protect the brand, the trust, the intellectual property. We don't want anybody getting in there and stealing anything from the corporation and taking that elsewhere. So those are really what's top of mind when we're saying, okay, here's why we need to protect this network. And that's where we can introduce the challenge. And this is the access versus security challenge, or OT versus IT conversation that I'm sure a lot of people on this call have gotten into over the years. What that's about is vendors and third parties need access to remotely troubleshoot, support, and maintain these systems. It's a legitimate need that people outside of the corporate walls need to have access. These sites are spread out. They're not, in somebody's backyard. There's a distance between something goes wrong and I have to get to that site and support it. There's new requirements that are coming out. So we're seeing requirements from compliance, both internal and external. We're seeing cyber insurance, say you have to meet these particular objectives. We're seeing global standards that we'll highlight towards the end of this webinar. But all this is pointing to the fact that, human error, things going wrong, bad actors on the public internet cannot get in, right? The human error needs to be eliminated. People try to trick staff and contractors all the time. It's as simple as tricking them to install fake software updates, fake patches. You could transfer a file to somebody by accident, and then all of a sudden that introduces malware into the network. You can't rely on the trust that's baked into something like a VPN. So how does this translate into what the customers are saying? So what our customers, what your customers, potentially your IT groups, what they're all trying to achieve can be boiled down into a few simple things. So to recap everything that we've covered thus far, what we really need to do is secure access into those private networks. That needs to be done from anywhere in the world. Your vendors, the people who support your production lines aren't always in your backyard. Maybe you bought a system from Germany and there's staff there that needs to connect in. I'm sure some individuals have Siemens or Rockwell PLCs in their environment, and chances are you're not in the same city. So they need that remote access in. We need to increase security and air gap those mission critical systems, right? We need to maintain that so nothing bad can get in again. And then improve operational efficiency. It all comes down to uptime and allowing vendors to access. Has to be dead simple. We can't introduce more processes, ideally within a single click. And again, reliability, making sure these are available when they need to be available, and you don't have to jump through hoops to get there, double VPNs and all that fun stuff. So we're going to dive in a little bit deeper in terms of the architecture. At this point, I'm actually going to ask my CTO, Nick, to take over for a second and start to explain how this is done today. But maybe I should warn everyone about the next slide. It can get a little graphic, but I'm sure everybody's used to that. So definitely brace yourself.
Thanks, John, and please take a breath. Excellent. So John mentioned quite a few things that are interesting. So for example, how did we inherit an inefficient system? Where does the access versus security debate comes from? And where do we typically start from when we go today into an OT environment where VPN access is pervasive across the OT network for access? And how did it, why did it get that way? So this is a traditional architecture that we're looking at in the industrial control system realm. It's pretty close to the reference architecture, what we call the Purdue model, which interestingly enough, in my opinion, has these 6 zones, but leaves off the most important one that's created the schism that we have in the security versus access. So at the very top, like John explained, we have the separation from the IT network to the OT network, and that's really been done on purpose. I mean, this is a 30-year-old model. And what's most visible to you are really the red lines here, where we're trying to build that half zone or the DMZ or the air gap. And one thing that's noticeable to anyone that's moved some products to the cloud here is a notion of perimeters. And those perimeters are effectively have disappeared. Many people have called the DMZ effectively ineffective or dead or overrun, if we want to speak in the military language. But essentially, John was mentioning VPN access. We have actors at the top. We have our engineers, our plant managers. We know them, and how do we know them? Well, we've given them credentials. There might be an untrusted contractor that's reusing a shared credentials. Again, how do we block them, or how do we allow them based on their permission level, based on their credentials? We know who they are. They work for us, or they work for a contractor that works with us, and therefore we allow them into the top layer of our IT network. At the very bottom there, we have then the industrial zones, or what we call the manufacturing zones, from 3 to 0, the control system zones, the intelligent devices zone, and then the hardware zones, for example, that can control wireless networks or serial networks to our sensors. The important part of the conflict between the security and access has always been about the DMZ, and there's a couple of reasons for that are fairly obvious. The life cycle, for example, of products in IT tends to be a lot shorter, so we tend to evolve these products quite quicker than we would in an OT zone, and for good measure. I mean, the operation technology is not necessarily about being the latest and greatest, but being stable and rock steady. There's an acceptance of risk at the upper level there in the IT for disruption, and disruption typically means network outages, means loss of revenue or loss of productivity. We understand in the industrial zone, disruptions can be a lot more severe. These can be industrial accidents. It could be water treatment plants, like John was mentioning, that make the news way too often. So that there's serious consequences to disruptions in the lower OT networks. And therefore, the DMZ was thought of as a good halfway point to air gap access into these zones, whether from the manufacturing or control system. Now, when we look at the traditional architecture, what products are deployed to allow limited access, where we have these green boxes, for example, to permit, we quickly notice that the type of nodes that are deployed are not necessarily application specific. They're really a means to an end. And so is VPN. We don't deploy VPN into the industrial zone because we want to give layer 3 access and be fully opened. Like we would in the cloud, for example, without a perimeter. It's really a means to an end. We want to give access to a solution, to a product, to a control terminal unit, for example, and therefore the VPN, is sort of a kludge where, yes, we allow level 3 or layer 3 access, but then we try to restrict where they can traverse east and west, and that's really where the danger is, and the surfaces that we have as threat vectors for actors coming in, either with nefarious purposes, or sometimes it's just that the plant manager's laptop is compromised and there's malware, and all of a sudden now there's a VPN that gives them access to that device to the lower layer. So the identity of these actors are of the personnel at the top today is known, but it's quite archaic in that it's either a shared credential or a plant credential that we may have. The second one is the access. We typically provide today remote desktops, layer 3 VPN access as a means to an end to get really to a remote terminal unit, to a SCADA, to a historian, for example. But the goal here is really to give access, and that's where there's a push and pull conflict in the DMZ. We continuously patch, we continuously make exception, and the reason for that is there's a little bit of catching up happening in the OT space. The catching up is, well, these devices may not need internet access, but now we upgrade them to sensors that either as IoT, for example, that require internet access to share data because we may be basing some of our production on analytics tools that are moving to the cloud, and therefore we have a requirement for the sensors at the lower layer to actually not only get to our IT space, but get directly into the cloud. And some manufacturing decisions may be coming down from the cloud as well. We talk about work from home, but I think the hybrid workforce of the contractor that's currently sitting down in that graph next to the laptop in the location, first of all, that's money, that's time, and that's effort to get these credentials into facility and networks. And if we can simplify that by having a much shorter downtime, by having that contractor or that human resource directly accessing down to that resource from a remote site without compromising security, then we've really solved the dilemma of the DMZ here that's failing us. And lastly is really the alternative to what a VPN provides. We need to start thinking about who needs access to what, having security by default, and understanding that the IT layer lifecycle of software tends to move away from OT, but the OT legacy software needs to be respected and still needs to be accessed, to still needs to be maintained, and there's always going to be a requirement to get there. And if we can marry the two, marry the advancement of the IT space, for example, either through least privilege permissions to access these resources, prevent traversal from one application to another, and also leverage identity to get these resources, whether at the top, whether at the bottom, or even remotely, to these resources become extremely important. So a couple things to remember here is the perimeter is dead. Those red lines are pretty much gone in all of the IT world, especially as we move to cloud. The green boxes that are permit or are the exceptions to our air gap have become the norm. There's more exception today than there are blocking happening on that firewall, and sometimes maintaining those becomes a huge toil for the IT group, and a disconnect occurs between the OT and IT groups as to what type of level of access both the devices but also the human element needs into these networks. So let's simplify this. Let's make access secure by default. Let's leverage what we know to be true, identity and resource access, and let's make the OT network work better. And I think that's really a good approach that we can deliver here at Agillicus.
Thanks, Nick. That's incredibly insightful. I might actually go off script for a second here because I think a lot of the stuff that you said is pretty valuable. 30-year-old model, inherent risk where there's more trust than there is restrictions in terms of, it'd be great to have a model that simply whitelists what's allowed versus, blacklists. It's a flip from IT. Where do you see this from the customer engagements that you have? Where do you see architectures like this break down the most?
Yeah, it's truly in the DMZ. I think there's a desire to access devices in a secure manner. We start making exceptions, and exceptions become the norm. And then we sort of lose control over our firewall until such time as we get a breach. And that's where we step back and say, okay, we've been sort of accepting some level of risk, some level of disruption in our IT, and now we've infer that into our operational technology or our industrial control system network. And then we get to a breaking point where we decide, not only are all of these firewall rules and management and the toil that is required from my IT group to maintain that unacceptable, but even providing the minimum secure solution that we do today, sometimes with just VPN, is no longer sufficient. We either need to augment the VPN and have very restrictive layer 3 rules or firewall rules for the traversal, so hardening those systems, which basically infers even more toil for the IT group. And that's where I think the zero trust model, least permission model, and access control for these applications become very important, because it's very simple. You don't want the toil and the overhead of having to manage all of this. You already have very strong data on identity. You have data on the applications that need to be used and when they need to be used and who needs to use them. And you can do so in a default secure model. So that's really where that comes from. The DMZ is, or the air gap, as you mentioned, as you were calling it, is really where this is failing. And then I sort of mentioned it a little bit. The level of change in the IT network over 30 years has been tremendous compared to the OT network. But that doesn't mean that the OT network doesn't deserve to have its own security by default and the right tools at the IT level to get into the access and management of these control systems.
Well, in that same vein, in terms of the right tools, I mean, we've been on a ton of different calls with customers, and we hear things like double VPN, then RDP, all this stuff. You know, in terms of roadblocks, what do you see as the most common roadblocks in this model?
Yeah, so I was mentioning a little bit, these tools are really means to an end. If you think about what does the end user need, what does my contractor, what does my factory floor worker, what the person that runs their remote terminal unit, for example, what access do they need? What vendor access do I need to provide? And very easily, I think we can say, oh, I'll just throw a go-to a remote desktop, for example, or a team viewer, and I'll entrust them to do the right thing and use it within the IT or OT policies that I have. What we don't account for is compromised devices, and malware and ransomware that can then leak in through no fault of the contractor. There's obviously bad actors, but most of the time, the secretary that opens the email telling her about something from a spoofed email that then installs malware that then propagates east-west and just waits for the right opportunity for a VPN to make resources available, it has a tremendous cost on the OT network once it gets compromised. And that's really, having these tools is no longer good enough. And I think we're either self-regulating or mandates are going to change, or best practices guides are going to change for that to become a lot better from a security perspective and from an identity perspective as well.
And so I might ask one more question before we move on. You mentioned the cost and the cost of various things happening. What's the value to the organization for going back and revisiting this type of architecture and potentially streamlining it?
Yeah, so there's a couple costs there. It's just also cost savings. So you probably are back against the wall and you don't want to spend $1 more than you do today, and that's completely understandable. Margins are either low or budgets are low. Or shrinking. You want to have the best solution, and maybe you're spending licenses in systems that are like 40% meeting the objectives of what you want, but they're a means to an end. They're good enough, but security is lax. The cost of hardening that system might be too much. So the budget, for example, is one. The second one is the outage. What is the cost of an outage from both a productivity, let's call it revenue, but also from a security perspective? What is the impact of my intelligence devices misbehaving, of that data being abused, or, for example, the connectivity being interrupted, or the data being changed? If I change my historian data from a governance, risk management, or compliance, there's huge penalties there, but there's also a reputational cost. So we were talking about financial cost, the human cost, and reputational cost. And all of them, can be quantified, sometimes through just, for example, an insurance policy for your OT network against data breach that can be quantified. So there's a cost there, and the cost of doing nothing might be actually greater than people think.
That's an interesting way to look at it. Okay, I appreciate that, Nick. So on that point, I think what I'm going to do is dive into the rest of the presentation, and we're going to start to explain how this can be a little bit different, how we do it differently for customers, and then what you can start to look into. And of course, Nick is actually going to pop back in later on to do a demonstration of connecting to one of our live OT environments. So on that note, if I can take the presenter, there we go. And so what we do is we implement a zero trust framework. So we simplify the previous slide when it comes to access, because we do an all-in-one zero trust access framework. What this is, I will break this down for you, but there's really two components to worry about. We need to know an email address of the user who needs to access, and we need some place where our software can live within that secure network. The platform handles the rest. So let me explain this a little bit more. On the right side of the screen, this is your OT network. We don't install any new hardware. You have your existing infrastructure in there. What we do is create an outbound only connection to the back end of our cloud. This goes outbound only through port 443 in the firewall. At this point, nothing is on the internet, nothing is reachable, nothing is scannable. It doesn't exist. It's simply an outbound only connection. At the left side of this diagram, when a user needs to access something, so if you need to access a workstation, remote desktop, a web application, anything of the sorts, a user simply opens a web browser and they're asked two questions. Who are you? What level of access do you have? Once they answer those two questions, our system takes those two outbound only connections, splices them together, and allows a user to access a single resource under this least privilege model and zero trust model, instead of connecting that user to the network. So everything we described above is not relevant in this model because that user is never directly connected to that network. So those issues and threats go away. At this point, when we map a singular user, there's a couple key points that I should point out. So on the left side, this could be multiple users. So when I talk about single user, this could be somebody who works for you, somebody who's a vendor or a third party, or potentially is working for another arm of a manufacturing environment with a different domain. We use existing identities. So Nick referenced a lot about people have an identity and we know that about them. I have an email address. Likely everybody on this call has a work email address as well. We know that with full certainty. We use their own corporate email address. And what we do is we extend that across all access. So we don't have to worry about managing passwords, somebody getting fired and still having access. All that goes away. We say, what is your email address? We put that in the system. That goes back to my first point where you need two things. In any given example, an OEM that supplies anything. I use Siemens in the past as an example. If we use Siemens as an example here, they might have thousands of remote staff that need access. And so you don't know fundamentally if somebody gets fired, if somebody says they're going to go crazy and blow up all their customers. You are unaware of that. You're trusting Siemens as an organization. What we do is we say, trust that one individual. If that individual is no longer working there, has caused an issue for the company, poses a risk to your organization, they're deleted from their own corporate Active Directory, and automatically their access is severed because they can't answer those two questions of who are you and what level of access. So because of this, we also audit every single action that's done on the network. You'll see that towards the bottom of the diagram. We know the identity of every single connection, and therefore we can tell you who made that change at 3 p.m. yesterday, for example. But the firewall, I mentioned, we go outbound only through port 443. What I said previously in the webinar is that you've invested a lot of money into these firewalls, and that's to protect the environment. That's to make sure nobody gets into the environment. It's a wall. The VPN allows somebody through that. What we do is we basically pull that single application out of the environment with the magic that happens in our cloud, and we pair that user with that single use case, whether it's a web application, a remote desktop, various PLC. Instead of allowing it through, pull them out, pair it together, and what that looks like in the end is this, at a bit of a closer level. So we have various security precautions at every single level throughout this connection. So a user opens up their web browser. It starts with federated identity at the top. And the federated identity is the fact they can use their own corporate email address to get through and to prove who they are. We can then inject a multi-factor, so we know that it is in fact them on their email address and they're holding their phone. And so we know it's that person and not somebody else trying to be that person. And then we can go right down to role-based access controls. John has view-only access to this one particular thing. And in the process, we block the top 10 threats that everybody is worried about and why we're having this discussion to begin with. What the end result of this is what we term the modern air gap. So when you want to air gap things, you want to separate things. What we do is we do that with our software. Because the VPN scenario that we talked about earlier, a user getting through, a user is never connected to that network in our model. They are never directly connected. Nothing on their device can spread into that network. Those risks are gone. Instead, in this example, we have two users. One's a vendor who needs to support a PLC. They're sitting at home. One's a senior leader that watches various dashboards from the corporate network. Everything happens exactly how we described it previously. We create an outbound-only connection for the HMI. We create an outbound-only connection to the dashboard. Those go to the internet. The users on their devices, whether it's an unmanaged device sitting at home or a corporate device sitting on the corporate network, they go out to the public internet and we splice that together to make it look like it's a connection inbound. The user does not know the difference, except the benefit, all the risks we spoke about before are removed. The end user can access it, they can still get their job done, but you don't have that risk of exposing your network by using a firewall, by using a VPN and allowing individuals through your firewall. So from an end user perspective, what this looks like is exactly as it looks like today. The way that they open things up and connect to things, it will look the same tomorrow. They don't have to connect to the VPN, it just works. There's no risk of them moving to another system in the environment. There's no risk of them transferring files in or out of that environment, stealing information, introducing malware. The most powerful aspect of this approach and this platform is the simplicity of it. And so our goal really across the board is to ensure that we bring the highest level of security, the security level that you think is baked into a complex model like Nick talked to before. We want to make that invisible to the end user. They don't have to do these double jumps. They don't have to go to a jump box and connect from there. It just works from wherever they are, from whatever network they're on. The corporate environment, the operational technology environment is protected no matter what. And so to demonstrate this in a live environment, Nick, I'll actually ask you to take control of the presentation and go through from there, if that's all right.
Absolutely. So let me just take presenter here. All right, perfect. So in the demonstration, I think I want to highlight a couple things that John was mentioning. What does that look like? So let's look at the standby generator that we have here at the office. Assume it's in a control system zone, for example, of an OT network, and it coexists with other devices. Let's say here, either in a power generation or specifically power monitoring. So I have a generator, I have a power monitoring station, and I only really want to give access either to someone on site that is my IT network, for example, today on my second floor, or I want a contractor from the vendor to come and troubleshoot this generator or look at statistics, for example, or its service history. So I want to expose this. It must not be visible to the public internet, so I can't reach that on the internet. I can't open a hole in my firewall to allow people to come in because they would traverse my network. I don't want to give VPN access because then they would be able to reach other systems within my network. I need this to be available at all times, and I need it to be available on demand if there's in the case of an emergency. So to really go back to what John was mentioning, the credential that we're going to use is an email address and identity that can be confirmed by an identity provider. And this could be my corporate email address, it could be my Gmail address, it could be my Apple address, it could be an Azure directory address, it could be an Office 365, for example. there are many bodies in the OpenID or OAuth type environment that can confirm who you are because you've provided the right credentials here to do this. So we're not going to manage password. We're not going to see password. I'm not going to ask you for the password within my generator, but I'm going to verify what your email address is. The second thing is, how do I get there? Well, first is I'm going to have a connector device that John was mentioning that connects outbound. Now, where do I place this? I could put it in a local server within that industrial control system zone. In the case here that we're using, literally we're putting it on an embedded router. So there's a pfSense or Ubiquiti type router with an embedded operating system like Linux. Our connector software is very small and it's deployable on many types of infrastructures, components, routers, switches, small servers like a Raspberry Pi, embedded controllers, Windows and Linux and a bunch of other devices like this. So the idea is that I can have multiple connectors across the different zones, for example, of my reference architecture that only really connect the devices within that zone, but don't let services or users traverse across services or across nodes or endpoints or terminal units within those zones. Like John was mentioning, it's not a VPN. I only want to give access to the resource that I'm exposing for that single user. So let me just switch quickly here, and I'm going to share my screen. And just to keep in mind what I'm doing, I'm just going to overlay both the slide that John was showing, which I think is very interesting, which is this one. How does the zero trust access? And just want to give you the analog of really what that looks like from accessing that type of resource. So on the left-hand side, I have either an employee, a contractor. I have an identity that I have and for which I've been granted access to a specific application, in this case, a generator. So I'm going to actually then look at my bookmarks. And what I've done is I've exposed this generator under its own host name on a demonstration domain, which is egov.city. You can see from the screen that it's genmon.cloud.egov.city. And then I can reach that on the internet. And immediately what I'm presented with is a platform dialog in the cloud to confirm my identity. Now, I could be an employee, so I could have a certain level of credential to provide here, like I'm Joe at domain1.com, like in the example, or I could be a contractor. And I may want to choose to have a higher level of authentication and authorization process for third parties. So I've enabled this for my generator because the generator that I have here at the office, I don't want people to go in, and if I do, I really don't want them to traverse from different services. So I'm going to force MFA. Now, how do I do this? I may already have multi-factor authentication on my own domain, but I don't know that a contractor does, for example. So in an Office 365 or Azure. So I'm going to sign in. And you see here the identities in my Chrome browser that are pre-cached offer me both my Nick and Agilicus corporate email address. And if I want to log in here, it'll be fairly quick. I'll just go right into the generator. But I've enabled my personal email address. So think of this as a contractor, someone with another identity. So when I choose this here, you will see that Chrome doesn't ask me for my password. The reason for that is the browser I'm presenting to you with the camera on is my Chrome browser under that account. So there's already a live session. I can go to Gmail without retyping my password. Therefore, my identity has been confirmed here to the system. What I've done, however, is given the identity that I'm using, I want to force multi-factor authentication. I really want to do this because it's, let's say I'm a contractor account, and therefore I'm not an employee. And if I'm going to go in, I want in the audit portion of the center of that solution that John was mentioning, I want to have a non-repudiated record of who is that person and what factors or what I use to confirm my identity. So I can use, for example, a rolling code here in a verify, or I could use biometrics. So if I want to use biometrics, I've enrolled my code, my phone. The reason I've enrolled my phone because I have an Android phone under my personal home account at gmail.com, and this is this phone here. And when I do this, I literally, like you would 10 times a day, need to all of a sudden unlock my phone with my thumbprint. So that's the factor I'm going to provide. So now I've provided two factors. I've provided my sign-in with my Gmail account, and I've provided my thumbprint. So I have a clear identity confirmation of who I am, even if I'm using a shared credentials to then get into that resource. In the case of this resource, there's no password. So this is a monitoring device that does not have the concept of user authentication, and you can understand now why I would never expose it on the internet. I would never make this available. There is no logs on this piece of software as to who the identity of the user is, just that it loaded the interface. But because I'm using a zero trust network architecture with least privilege, I know exactly who. It's me, and it's at 1:50 p.m. and I actually access this. John mentioned also in the center piece here that we have web application firewalls. So I could design beyond what the application intended uses different roles. So I could have a viewer role where I can actually see all of this. I can see what my maintenance is. I can see the outage log, but I cannot click and start the generator. So for example, here, I have given myself full ownership of this generator. And if you think this is a mock-up, it's not. So I can start the generator, for example, but I may not want anyone else to transfer the generator because I don't want the utilities to flip in the office. I only want to actually be able to start or run the exercise of the generator. So you will see, for example, here the output voltage of the generator just started. I'm actually generating power, but I'm not transferred it, so the generator is actually active outside right now and running. I do not have the ability to traverse, for example, right now to the power monitoring system. It might be residing on the same machine. It might be co-residing in the same industrial zone of my OT network in the control system zone. It might be the IP address next to it. I cannot reach it. I do not have accessibility to that. I cannot traverse east-west into that resource. And the reason for that is I've only ever connected to the system like you see here in that topology. Here we have a SCADA system, but it could be a remote terminal unit. The connector has only validated my identity against this specific resource. So that's the only resource I'm going to be able to access. I can have different roles in that resource. I can have different areas to click. I can have a web application firewall that really limits the ins and out. But ultimately, I've done three things. I've confirmed who I am, even if I were using a shared credentials, for example, on the far end. There's an audit that's been generated. I know exactly who I am. If I no longer work at that as a contractor, my email address might be disabled on a seasonal basis, for example, or from an employment basis, and no longer work. Like John mentioned, what is the level of access that you have to this resource was determined here in the Agillicus platform. And the last one is how. The Agillicus connector was routed out to the cloud, and like John mentioned, it spliced those connections together and delivered this system to me. Now, the Genmon cloud here, that's not hidden. You yourself can load that up in your browser. You'll be prompted for the same authentication dialog. The thing that is stopping you from accessing this resource is you have not confirmed, first of all, your identity, but also access has not been granted to your identity. Now, the question is, how easy is it then to make people access this? Well, like I mentioned, we don't use passwords. We don't make you change your password. Adding your identity, like I have on the left-hand side here of an employee or vendor or contractor, is the only method that I would have, which is very quick. Basically, what's your email address? It could be john@agillicus.com, and you have access to this resource as a viewer. Who, what, when, who, what, how, and then you have access to this resource. And I can log out of that resource the same way that I logged in, and be prompted back into this the authentication interface. I can choose to be more lax and allow a single sign-on across resources or groups of people. But again, it's always about who you are, what identity you've provided, what resource you have access to, and how you're going to access that resource. That makes sense, John?
That makes complete sense. So I appreciate that. I'll take the presenter role again from you. So just to summarize there a little bit, Nick just did an excellent demo. He focused on one particular HMI that we have in the office that sits against the generator, but the use case doesn't matter. What we focus on here is there's something that shouldn't be on the public internet for any number of reasons, and we need to get access to that remotely. How do we do it? We do it without a VPN because the VPN introduces new risks into the environment. And the individual accessing it, it doesn't matter their role within the organization or external. It works for everybody across. If somebody on this webinar, for example, wanted access, Nick would just simply put your email address in there and could grant you access if we were willing to do that, but I don't think we are, unfortunately. Why is this important? Let's focus on this. I know there's a few minutes left, and I think there were a couple of questions that I wanted to circle to, but let's run through the next few slides pretty quickly. So why is it important? Well, all of the standards are starting to move in this direction, the direction of zero trust. We've seen this in the upcoming standard from NIST. I believe it's in its draft format right now, and it'll be pushed through in 2023, early 2023. We've seen these same principles pop through in ISA, IEC 62443. Zero trust helps fulfill what the requirements are, this least privileged, least route methodology. That is what Nick demonstrated. He only has access to the generator. He cannot go laterally anywhere else. And of course, we have a full audit of that. So when Nick logged in, began his session, logged out, everything he did in between, we've recorded all of that in the form of a log that can be sent off to a SIM. And finally, we're seeing this across government agencies as well. There's been executive orders on this. There have been pushes from CISA and the rest. So why is it important? Everyone else is starting to tell us it's important. It's not just us preaching it anymore. From an outcome perspective, this is really the end result in terms of you achieve the current industrial security standard as well as future industrial security standards, which makes the IT part of IT versus OT happy, right? That is what they're shooting for, the ultimate level of security, because they're responsible for that risk. This is how that is satisfied. From an implementation perspective, it's instant. We're talking 15 minutes to actually set this up. It can run in parallel to existing environments. It does not impact them. Again, the only real requirement is that that software has to live somewhere within the network. As Nick mentioned, Raspberry Pi, router, Windows machine, VM, you name it, it just needs somewhere. This is the ultimate micro-segmentation strategy. If you had arguably a completely flat network and you implemented this tomorrow, this would micro-segment down to the device level, potentially the application level. You can expose a single application within an RDP session. So there might be 2 applications on a particular desktop. Nick might have access to both of them, but I only have access to application 2. And when I log in, I only see that. So there's various use cases that can go very, very granular. The local config never changes. If the IP address changes, it doesn't matter. We don't require any ports other than outbound through port 443. So as these local IT teams work with their own network and change open, close ports, add rules and policies, this access is always maintained. So from a support perspective, you are always able to fulfill your contractual obligations for support. And again, it all comes down to, this is about avoiding downtime, right? This is about allowing users and third parties to access the critical systems that they need to access while taking care of the security risks. The value for the customer is fairly simple. We've covered a lot of this, so I won't spend much time on here. Enhance security, increase the operational efficiency, but make sure it's seamless for the end user. It's not about jumping through hoops and double VPNs and VPN to RDP and all these jump boxes. It has to be seamless. Just like Nick opened up a web browser, clicked on a bookmark, all they had to do was click login and he was there. So I know we have 2 minutes left. I want to make one offer to the folks on this call because it is an important topic and it's very timely. So by all means, usually we say, hey, happy to sign you up for a demo, and I'll put the contact information for that there. But I also want to make this available in that, if you're thinking through this and you're thinking how to address your industrial network, we are more than happy to work with you and give you a review in terms of whether your network is air-gapped or not, and that would be working directly with Nick and his team. So feel free, my contact email is right there, john@agilicus.com. So feel free to shoot me an email. I'll leave this slide up for a second while I check in on the chat to see if there's any questions. So feel free, again, at this point, if there's any questions, pop them into the chat. I am going to scroll up a little bit to see how many of these I can address. Can you access multiple sites at the same time? Angelo from our team did answer that, yes. And in fact, that is true. So just like Nick opened up a web browser and went to a single link, he could go to another link in another tab that's connected to a completely separate site. There are no issues with that.
I can address the question about Bastion in that now what we've demonstrated here is a website that exposes an application resource, in this case a generator monitor. The solution supports much higher level types of integrations as well. So those could be your standard RDP and SSH, for example, that you see in Bastion, though we do it differently. It's very transparent in the way that we do it, in that the end user doesn't even know that they're actually using a gateway sort device to access machines behind an air gap, for example. It's very transparent, pops up the same authentication dialog, pre-configures your SSH sessions. But we also support things like file shares, which become important when we want to retrieve logs, that are completely native to Mac, Windows, and Linux. We also support thin and thick application, Java apps, for example, that need access to, or SQL access to a backend, very thick application, C#, C++, for example, that are required, for example, for a contractor to access maybe the hardware devices or the actuators or sensors. They can now run those remotely, and we have the ability to develop a launcher where that application actually traverses all of its network traffic through the Agilicus platform. So they have an application that may be a legacy application that needs backend access or sensor access. They start it, they get prompted the same way I demonstrated with their credentials into a browser to put that in, and then a network connectivity is established into whether the control system zones or the device zone, for example.
First webinar, and you're already showing me up for your answers, Nick. This is, I don't know where we're going to go from here. But to grab a couple more here as we're at the end of the webinar, and feel free, if you have some that are lingering, fire them in, email us, anything works. Does this replace TeamViewer, and will it work on cellular and remote sites? Yes and yes. So we focus on the connection method, the use case. We are agnostic to. We have a ton of use cases with something like VNC, where two people can watch what's happening at the same time. Run me through what you did so I can see where it's an issue. Cellular sites, things with no public IP address, fantastic use cases for us. We do not use public IP addresses, so it's not an issue.
Just to be very clear on that, a lot of the mobile networks, and even more so satellite networks like the low Earth orbit, like Starlink, uses carrier-grade NAT. So you're never given a public IP address anyways. John explained that the connector only connects outbound, so whether you're natted, double natted, or there's a firewall, as long as it can connect outbound, which all devices do on cellular networks, for example, the solution works. So we do have customers that are in very remote areas, either oil and gas, for example, or maritime, that have Starlink or cellular backhaul that are going through carrier-grade NAT, and they can't provide inbound access to those. So they use our solution to connect outbound with the connector, and then expose their systems for vendors, for example, or for control systems.
Yeah, and I think just because we're over time, there's a lot of activity on here, and perhaps we can follow up with a few offline. The last one that I see, I'm getting lost in the translation a little bit, but are about clients. Is there a client when you did that demo? And Nick, I mean, do you want to take this one?
Yeah, sure. So like I answered it as well, but there was no client in there. So the point of access versus security is a dilemma that John mentioned, is that you want security by default. You don't want it to be an extra step into the workflow to get to resources. So whether you're accessing file shares, whether you're accessing remote desktops, VNC, printers, for example, or even remote system, there's no client-side requirement. There's no VPN client. There's no zero trust client. We expose this, and then we make the identification process transparent. Now, as I mentioned, we do have something called an agent that is like a helper for Windows, Mac, and Linux, for example, that helps employees or user of the platform quickly identify the resources that have been shared to them. It could be, for example, a seasonal worker or a floor employee, and they need quick access, for example, on a mobile device to a desktop or to a file share. And we have a small helper agent that shows you what's been assigned to you, and you can quickly access it through a bookmark, for example. But that doesn't take part into the connectivity.
Yeah, so if I could just summarize that, the short answer is no. The long answer is we also make that available if individuals find that more convenient for them, they have the option to download one if they choose, if they're used to it for, say, like a VPN.
And I was asking about file transfer. So yeah, so you can expose file shares. You can expose NTLM file granularity in these file shares to end users based on their identity. We have quite a few vendors that need access to some of their equipment for maintenance logs, for example, in a very remote site where the share can be read-only, so they can retrieve the log files, or read-write on a per file per directory. And it's completely transparent. It goes through our system. There's an identity process, the same one that I showed you when I accessed the generator. Confirm your identity, and then we can either automatically mount that file system, use a WebDAV interface, which is web-based, which is very friendly, or manually map those drives into, or automatically map those as drives into a remote worker's laptop.
Perfect. So I think with that, a lot of the other ones have been captured. I will still encourage everybody to reach out, whether it's to the info at Agillicus, myself, John at Agillicus. I'm more than happy to connect you with Nick. And from here, I mean, if we haven't answered your question, we will follow up with you offline. I really appreciate the time from everybody today, and hopefully you learned a little bit more about how we're approaching this VPN-less access into the industrial control networks. Thanks, everyone.